In the last video, I mentioned that if you take the limit as x approaches a of a polynomial function, you could just substitute a into that function, and the limit would equal p of a. And I said that that also worked for rational functions. Rational functions are just the quotient of two polynomial functions. So you would get p of a over q of a, as long as q of a did not equal 0. So let's look at an example here. Let's take the limit as x approaches 2 of x squared plus x minus 6 all over x minus 2. So let's go ahead and try direct substitution here. If I took f of 2, I would have 2 squared plus 2 minus 6 all over 2 minus 2, which would give me 4 plus 2 is 6 minus 6 is 0 over 0. Now note, 0 over 0 is not 1, nor is it 0. It's actually what we call an indeterminate form, and you'll hear that word mentioned throughout the course. 0 over 0 is an indeterminate form. So we're going to have to do something to change the form in order to find the limit. And so this is where we use factoring. All right, that's the technique here. So I'm going to factor the numerator, and I'm going to factor it into x minus 2 times x plus 3, and that's all over x minus 2. And since we're not concerned about what's happening exactly at 2, we're only looking at what's happening around 2, we can actually cancel these factors out. And so we know that as long as x is not equal to 2, that this function, x squared plus x minus 6 all over x minus 2, is equal to x plus 3 as long as x is not equal to 2. All right, so I'm going to use that knowledge that these two behave alike as long as x is not equal to 2. And I'm going to take the limit as x approaches 2 of x plus 3. And that gives me 2 plus 3, which is equal to 5. And so we know that this limit is equal to 5.